Hello and welcome to the demo of my Micro P2 final project that I have titled RTOSTris. What is RTOSTris? Well, let's talk about it. So first off, we'll talk about kind of what sort of Tetris I'm trying to make to begin with, because there's different flavors. We'll talk about kind of a bit of how the project is structured, and then we will move into a live demo to see how it all works. So let's start with the Tetris info. So there's a lot of different types of Tetris. What I really wanted to make was a version of modern Tetris, right? People have been playing this game for years, and there's been a lot of new additions that have come up since then. So the way that works, so it's not just like, oh, place the pieces and get a score. Now, at least what I like to play and what a lot of people like to play is it's a multiplayer focus, right? So you're playing against other people. You're trying to be as fast as possible. You're trying to clear as many lines as possible. You're trying to be as accurate as possible, and then send lines of garbage to other players. So if you were the last one standing, you win. There's a website I used to really like playing Tetris on called RTOSTris, and that was kind of what I based the gameplay on. So that being said, what are some of these features that you might not find in a regular Tetris game? Well, first off, there's piece holding. The original Tetris doesn't have this, but say you get a piece, you don't like it, it would be bad for your stack, you want to put it somewhere else, you can just press a button, hold it. Next is an extended preview. In past games, you might only know one or two pieces in advance. In my implementation, it is 3. It's configurable in the code with minor changes, but I keep it 3. There's also the modern, what's called SRS or super rotation system, where basically it defines how the pieces spawn in, how they rotate, and how they can do wall kicks, where if they're against a wall and they try to rotate, it will move the piece. This also allows for advanced techniques like T-spins, which we'll talk about later in the demo. Another convenience is hard drop. If you know vertically where you want your piece to go and you don't care about holding down the down arrow, just flick up, it'll drop the piece immediately. And finally, the core multiplayer aspects of sending garbage and combos to your enemies. So that's kind of what we're going on with here. So let's talk a bit about how the project is structured. So the file structure, I kept all of the GatorTOS stuff by itself in its GatorTOS folder. Multi-mod drivers, again, mostly untouched, just kind of a combination of stuff I've done before. And then the meat of the project is in Tetris, where it is it's split into its different subcategories, which we'll talk about in a sec. And then we have some extra utilities like the graphics library, and a shuffle I had to introduce for shuffling up the bag, which we'll talk about. But yeah, so let's talk about what Tetris looks like. Very clean project structure. So in Tetris, we have a couple different files. For now, I had a structures file, which kind of defined the core definitions for the logical elements of the game. So what is the board? It's a 2D array of block objects. What's a block object? Well, it has a location, it has a color, and it has whether it's occupied or not. What's a tetramino? A tetramino is a list of 4 blocks around a center, and each block has an offset from that center. So kind of how do you logically define the pieces? Then runtime is how do you play the game? So using all the logical piece definitions, how do I rotate a piece? How do I clear a line? What are we actually doing to keep track of the game state? So stuff like counters for the number of lines you've cleared, or whether you just did a hard drop so you don't do a hard drop again. And then, of course, all of the threads. So, how am I going to handle the buttons? How am I going to handle the joystick? How am I going to render the display? When do I render the display? That usually happens after there's a state change. And then we have some supporting classes. I made a I made a custom menuing system for the multi-mod. So basically, it'll display a menu. You pick an option with a button, and then based on that, it'll return that, and you can do stuff with that. And then also, I had some extra multiplayer defines. For the multiplayer, it works through a UART interface, basically. So it'll send groups of characters to indicate what's happening. We'll talk a bit more about what's happening with that during the demo. But basically, it allows for a interface between the actual Tetris playing client on the multi-mod and a hypothetical server that would be, handling where to send garbage and keeping track of who won and stuff. So, alrighty, welcome to the Tetris demo. So I'm going to show first the sprint mode as 2 to show how this kind of works. I'm going to start placing some pieces. So you can see if I flick up, it hard drops. If I hold down, it'll go down. And so on and so forth. So right now I'm just kind of stacking up. I'm going to demo what is called a DT cannon, which is basically a technique in, I guess, if you want to call it higher level Tetris gameplay, where by if you place T's to clear lines, if you spin them into otherwise hard to get into gap, it'll send more lines to your opponent than if you were to just have cleared lines normally. So I'm going to use this to demo that I have wall kicks working. Basically, when you rotate and it wouldn't let you rotate otherwise, it'll move the piece off the wall. This took some time to implement, so I want to demo it, and we'll see what's kind of going on here. So as you can see, once I get the second T-piece, I'm going to try to get it into this gap, and I'm going to try to rotate it down here. Normally that wouldn't work, but with wall kicks, you can see that it'll work like this. So as you can see, I move that in, and then I will combo off another T-spin, and then I'll try to combo this into place. So as you can see, I'm sending a lot of lines, and because I'm continuing to send lines repeatedly, that is increasing the combo counter, which is increasing the attack. So I have a separate tracker for the cleared, which is the number of lines that have been gone through, and then attack, which is the number of lines you're sending to your opponent. So currently, I don't have special T-spin setups sending more lines, but I do have combos and all the line tables, so that'll be something to improve on in the future, but the core functionality is there. So that's kind of how this works. Let's say in sprint mode right now, you're never going to win because you're just trying to see how fast you can go, but I'm going to show what happens if you lose. So I'm just going to stack up to the very top. Once you hit the top, all your pieces turn gray, and the game freezes, and then you can restart to change the state of what you are working on. So now that that works, let's see how we could do other modes. So a big part of multiplayer Tetris is, of course, sending garbage to your opponents. So just as a proof of concept I was developing, I added a garbage race mode, which basically, instead of getting garbage from other people, every 5 seconds, the game is going to start sending garbage at you. And you'll see that, I'll wait for a sec to demo. There's a little indicator here of warning. And once you place a piece, whatever that is, however tall that is, it's going to create a piece of garbage to come up at the bottom of your board. Now, if you clear a line, whatever attack you would have had is going to counteract the amount of garbage that you get sent. However, based on the default ways that it's set up, clearing a single line by itself is not going to give you any attack at all. You need to clear at least 2 lines for that. So that's not really visible right now. I'm going to see if I can set up a 2-line thing to counteract some of this garbage. It's fine. But as you can see, the garbage comes up. Depending on your attack, that is going to reduce the garbage by whatever it would have been, and then send the rest of the attack to your opponents. But of course, as a single player, how do we play with other people? Well, for that, let me go into the multiplayer mode. So hitting multiplayer opens another menu where you can choose to be a host or a guest, and that depends on whether you're playing. So it's going to kind of be like a game lobby structure. So if you are the host, you control when the game starts and you wait for players to join. If you are the guest, you just join someone else's play and then their server controls that. And normally this would be on the BeagleBone because I don't have other multi-mods to test with and other people to run this on. I've chosen to instead just kind of fully flesh out the client interface. So let's try to be a host first. So you'll see we're waiting for guests to appear. And now it's time to show how the multiplayer functionality works. So I've flipped my camera around. I had to do some wacky stuff to record the multi-mod screen. So we'll see, I'm going to connect my multi-mod just using the NRF Toolbox app. And we can see I have some lovely macros set up. So when you are waiting for guests, right, pressing any of these buttons is going to start the game, but you need at least a couple guests. So when the server sends P over UART, either the Bluetooth UART or the BeagleBone UART, it is going to tick up the number of players in the lobby. So I press P, 1 guest in lobby, I press P again, 2 guests in lobby, etc. And now this is going to go until the host chooses to start. And so once the host starts, the game proceeds as normal. But now, whenever the client gets a line that is L for line, preceded by some character representing the number of lines to send, it will put that much in the warning queue. So I'm going to wait for this to fall. I'm going to hit L2, and you can see now there are 2 lines of garbage waiting for me. If I drop, that's going to show up. And of course, you can spam this, right? Send a lot of garbage. And then once you're done, you lose. So that's how that works. So now we can demonstrate how gameplay occurs if you're a guest. So similarly, you select multiplayer, You choose to be the guest this time, and now you're waiting for a start signal from the server. So it's going to be S followed by the number of other players that you'll be against. So once I press that button, you'll see game starts as normal, and now these lights light up to indicate that there are 2 other players playing. So of course you play as normal, you send lines, your opponents will send you lines, and with this implementation, you don't need to know who's sending the lines. You just need to know that lines are being sent, and the server will handle everything else. Similarly, when one of your opponents loses, the server will send an X followed by the number of that other player. So right now we only have player 1 and 2. I'm going to send X1 as going to knock out that player, and I'm going to send X2, which is going to knock out the other player. And so once that message makes it through, those guys end, toast pops up, you win. So with that being said, that is sort of the process for how RTOSTris works. We've got different modes, and of course it's super extendable. All right, so I hope you enjoyed that demo. I kind of want to talk about, so what did I learn from making this project? I think the most important takeaway was to always, flesh out your design before starting. The way I'd kind of gone through the project, I had my general idea for what I wanted the board to look like. I had my general idea for how I wanted to interact with it, but I didn't fully think through everything. I just kind of dove in. And so as my complexity expanded, as I started adding features, especially at the semi-final demo, it was starting to get really clunky and convoluted, right? I had all these things going on in different places. I was spending a lot of time in the debugger just stepping through things to see what was going wrong. And had I planned for all those in my design originally, created an API, created the interface and stuff, it would have been easier. So I had to spend a decent amount of time refactoring. What I eventually landed upon was a very streamlined process where I had one central background thread that would take in a FIFO of actions, and that action could be a rotation, or it could be a drop, or a movement, or garbage, or anything like that. And then it would process that accordingly, and then trigger a separate render thread. So that way, all of the actions would get carried out in one thread. There would be race conditions. The render thread would, again, only carry out once. Flags would control what to re-render, so it wasn't taking a super long time because the TFT screen is so slow. And in that way, I could have my joystick handler, I could have my button handler, and they would, wait for the button or joystick interrupt or, periodic thread, send those values to a FIFO. Those background threads would process that into an action and then send that to the action queue. So it was very, I had to utilize a lot of inter-process communication to make this work as smoothly as it did end up working. And again, another thing with the debugging, I ended up having a lot of issues with race conditions. There would be weird glitches in the rendering. There would be times where the piece falling and the moving would conflict, and they would cause a piece to get stuck at the very top and then lose the game immediately without anything having had happened. So it was definitely a lot of trial and error, and really reading through my code and streamlining things. And so with that being said, I think a really big takeaway is to make debugging as easy for yourself as you possibly can. So don't make a bunch of huge sweeping changes all at once. Change one thing, recompile, see if it works. And I got a little greedy towards the end. I made a lot of changes when I was starting to add the garbage stuff, and then my whole rendering pipeline broke, and I didn't know why. And then I went through, I stashed all those changes, put it in, and then I would just grab one component part from that each time, see if it worked, commit it, so on and so forth. And then at the end, eventually, what I had thought was the same code spread over multiple commits ended up working, and then I was able to implement the feature. So really important to make debugging easy. Over my whole code, I use a bunch of enums, defines, all things, so there were as few magic numbers as possible, and I think that really helped me out as I was working on my code. And also, it helps to make little helper debug functions for it helps to make various helpers for debugging. Like I had a thing when I was first working on my action queue, I would print out, okay, this is the action, this is the direction amount, yada, yada, yada. I had a thing where I would render the board to text in the UART console. So all these things kind of helped me figure out what was going wrong quicker and work on it. And, I think it was a really fun project. There's lots of improvements I could think to make if I had more time and then just return my multi-mod to the class. But I think it was a lot of fun, and it was a really cool project, and it definitely helped me learn a lot as we built our OS from scratch and then built something cool with it. So that being said, thank you so much for watching my demo. It's been a great semester, and I'm excited for what I will create next. Thank you.